Today in this video we're going to review what it means to multiply polynomials, but also we're going to reverse the process and see how multiplication can be reversed to divide polynomials. This is very useful for factoring, which we'll see in a later video. In this problem we have 2x cubed minus x squared plus 3x minus 1, so this cubic multiplied by this linear factor 3x minus 2, and it is possible to multiply using the rainbow method. So you would multiply the first one with the first one, and the first one with the second one, and then you would multiply the second one here with that one, and that one with that one, and so on, until you had all the terms in the first polynomial, that's not a very good color, multiplied by all of the terms in the second polynomial. Okay, and you would get 4 times 2, you would get 8 terms, and then you would combine like terms. So that gets a little messy, and so instead we can use a structure like this. This is a box, and in the box you see we have the cubic is listed along the top row, and the linear factor is listed on the left column, and then the 8 boxes are neatly organized for us to show the product. And so you can easily multiply 2x cubed by 3x, and 2x cubed by negative 2, and so on down the row. And you get the 8 different products. You will also notice that once you do this, your answer is not going to have 8 terms because you can combine like terms. So you might notice that there's only one term that has an x to the 4th, so this is a quartic. But we also have pairs of like terms, and they tend to sit in sort of a diagonal fashion. So we have these x cubed terms, the x squared terms, the x's, and then at the end a lonely little constant. We can combine like terms then and get this quartic here in standard form, and that of course is the answer to our product. Okay, so nothing too complicated. The question becomes, can we reverse the process to divide? And to first get you thinking about this, think about the answer to this question. If the product of this cubic and this linear factor is this quartic, what do you think we get if we divide this quartic here by 3x minus 2? Hopefully what's coming to mind is that the answer would be the cubic. So why is that? Well, think about a multiplication and division relationship with numbers. So for instance, if we had that 6 times 3, that's a times, equals 18. Okay, so if we know that, then what does that mean 18 divided by 3 would be? So we're reversing the order of the operation, and since 6 times 3 is 18, then 18 divided by 3 would have to be 6. Okay, so the same logic is true here with these polynomials. So let's take a look. Suppose that we start with a division. We don't know what the answer is yet. And so we're going to want to find some term here, some polynomial, that if I multiplied 2x plus 5 by that, I would get that cubic. And so hopefully one of the first things that comes to your mind is that this is going to have to be a quadratic. It's going to have to have degree 2. Because we have a linear term here, and we need a quadratic term here. We need some sort of x squared here, so that when we multiply, we get this cubic term. We can use a similar structure that we use for multiplication in this division, but we're going to have to think in reverse. Okay, so here's our 2x plus 5 that we're dividing by. And what we don't know is the other polynomial, the quadratic, and the 3 terms are going to go in those boxes. What we do, however, know is the answer. So we know what that product is going to equal. And we have to reverse engineer it, so we have to put these terms back into the box. Well, if you remember the last slide, the cubic, so the leading term, had its own box. So that can go there. Now the next two were actually a sum of like terms. So the squared terms are going to go in those two boxes. The linear terms are going to go in those two boxes. And then the 10 also had its own box. So this is our setup. So now all we have to do is think backwards and see if we can come up with all the empty boxes. Start on the first box. The 6x cubed has to be the product of 2x and what? Well, 2 times 3 would be 6, and x times x squared would be x cubed. That means that the bottom box then would be 3 times 5 would be 15 x squared. Okay, so I'm just multiplying the top box by the left box. Now, because these two diagonal terms are like terms that add up to 7, therefore I need a negative 8x squared here, so that when these two are combined, they make 7. And once again, I'm dividing. So negative 8 divided by 2 is negative 4. And I also need an x here, so that x times x makes the x squared. But now, negative 4x times 5 is negative 20x. Once again, I need a sum of negative 16. So this box must be 4x. And since 4x is 2x times 2, 2 times 5 is 10, and that completes our reverse product. So getting a 10 here at the end was good because that confirmed that I did all of my steps correctly. So therefore, my answer here is that 3x squared minus 4x plus 2 is that quadratic that I was looking for, and therefore that is also the answer to my division. Alright, time to try some. So on the next page of your packet there are 4 division problems. This is exercise 12. Pause the video and try them, and then come back, and you will be able to check your answer. If you fast forward to the end of the video, you'll see the 4 solutions to these 4 problems. But if you'd like a detailed explanation, continue to watch through the end of the video. Alright, so in the rest of the video we're just going to go over these 4 examples, and again, you could check your answer by going to the end of the video, and you might want to come back just to watch the ones that you had a question about or that you didn't get it right. So here we have x to the 4th. It's a quartic divided by x minus 2, so we're already set up. And one thing that you might be wondering is where do all these terms go, and how many columns and rows does my box need? So the thing that we know for sure is that the x to the 4th is going to go in the first box. And then these two are going to have a sum of negative 6x cubed. These two are going to have a sum of 18. Whoop, no they're not. Haha, just kidding. Why am I just kidding? I almost put 18x there. But I just realized that I'm missing an x squared term, and I need it. So these two terms are going to add up to 0x squared. Notice I'm missing an x squared term here. That means that these two terms are going to add up to 18x. And finally, the negative 4 is going to get its own box. Therefore, I do not need this last column. And in general, it is true that the number of columns that you'll need for your division is going to be 1, 2, 3, 4, the same as the degree of the dividing polynomial. Okay, so if we're dividing a quartic by a linear, we will need 4 columns. Alright, so let's get started. I start here in the x to the 4th box, and to get x to the 4th, I'll multiply x by x cubed. Now x cubed times negative 2 makes negative 2x cubed. But I need my sum, my diagonal sum, to be negative 6x cubed. So I need another negative 4x cubes over here. X times negative 4x squared is negative 4x cubed, but negative 4x squared times negative 2 is 8x squared. Because this diagonal sum has to add up to 0x squareds, then this box must be negative 8x squareds, and therefore negative 8x is up here, times negative 2 is 16x. And since I need 18x's, 2 more go here. Then this is 2, and 2 times negative 2 is negative 4. Check. Therefore, this right here is the answer to my division. The second polynomial division is a cubic divided by a linear. And here, the notation is just a little bit different, but it's still division. So I'm going to have my x cubed here. Oh, and because it's a cubic, I'm only going to need 3 columns. So I already know I'm not going to need this last column. And so therefore, I'm going to circle the terms that add up to x squared, and these two are going to add up to negative 14x. And I'm hoping to get a 3 in this last box. Alright, so there's x squared times negative 3, negative 3x squared. Because I need my sum to be positive x squared, I'll need 4 more x squareds up in here. Therefore, this is 4x times negative 3, that's negative 12x. And since I need negative 14 x's, I need 2 more negative x's here, times negative 2. But, oh boys, I have a problem. So what's my problem? My problem is that I was hoping to get a 3 here at the end, but I'm actually getting a 6. So what does that mean? Well, that means that our division has a remainder. I'm getting a 6, but I really wanted a 3. That means I have a difference of 3. So I have a remainder that I need to account for in my division. All that means is that the division doesn't go in evenly, right? So you might recall, for instance, if we did 52 divided by 7, nowadays you would type that in the calculator and get a decimal, but back in the day when you did division by hand, maybe long division, you would have said 7 goes into 52 7 times, right? With a remainder of, well, since 7 times 7 is 49, there's 3 left over that I didn't use, so there's a remainder. Or we also could say it's 7, and since there's 3 left over, we could say it's a remainder of 3 7s. So 7 and 3 7s. So with polynomial division, something similar happens. We can have a remainder. So think of it this way. If this had been a 6, then we would have had no trouble here. We would have gotten exactly what we needed. And this would be the answer right here. Okay, so we would have gotten x squared plus 4x minus 2. But that wasn't the case. So to make up for it, I rewrite the 3 as 6 minus 3, okay, which is equivalent, but it shows that that negative 3 then, that negative 3 right here is my remainder. And therefore, my answer is this minus 3, so there's my remainder, which is still divided by x minus 3. Okay. This looks a little fuzzy, a little complicated and confusing perhaps, but that's just what happens when two polynomials don't divide evenly. We won't see too much of that in this chapter, but just so you're aware, it could happen. Alright, next we have this seemingly simple looking polynomial division, a quintic divided by a linear. Here's x minus 1 over here, and big long table, how many columns will we need? Well, because it's x to the 5th, we will need 5 columns. 1, 2, 3, 4, 5 columns. So we won't need these last two. Alright, so our x to the 5th goes in this box. Notice that we are missing a whole bunch of terms. We're missing x to the 4th. So we have 0 x to the 4ths in here. We have 0 x cubes in there. And here we have 0 x squareds. And here we have 0 x's. And then finally, our negative 1 is way at the end. Okay? We really have to fill out all of these in order to get the right answer. So we get started. X to the 4th times x is x to the 5th, and x to the 4th times negative 1 is negative x to the 4th. But since I need 0 x to the 4ths, I need a positive x to the 4th here to make up for it. That means that this is x cubed times negative 1 is negative x cubed. To get 0, I need a positive x cubed here. That means that this is x squared, this is negative x squared, this is positive x squared, so they make 0. So this is x. X times negative 1 is negative x. To get 0x, I need a positive x here times 1, and then 1 times negative 1 is negative 1. Check. So this right here is the answer. So this quartic is the answer to this division. Whoops, don't need the pause there. Our last exercise, we are dividing a quartic by a linear, and so here our dividing term is 3x and minus 1, and because this is a quartic, we're going to need 4 columns. So 1, 2, 3, 4. We don't need the last 3. Woohoo! So 6x to the 4th is the leading term, and 5 is what we're hoping to get for the constant. So we have our diagonal like terms, negative 5x cubed. Here we have 10x squared, and then the last diagonal is negative 18x. So let's get started. 3 times 2 is 6, and to get x to the 4th, I need an x cubed here. 2x cubed times negative 1 is negative 2x cubed, but to get to negative 5x cubes, I need a negative 3x cubed up here. Negative 3 would be 3 times negative 1. And since I have 1x, I need 2 more x's. Okay, please double check that product, make sure it's right. Negative 1x squared times negative 1 is positive x squared. But to get to 10, I need 9 more x squareds. 9 then is 3 times 3, and x times x will make the x squared. And 3x times negative 1 is negative 3x. To get to negative 18x, I need 15 more negative x's. And since negative 15 is 3 times negative 5, and negative 5 times negative 1 is positive 5, check. Now we know the solution of that last division. These are the solutions to those 4 exercises. Please let me know if you have any questions, and I'll see you in class.